हरिः कर्ता।
So now let's look into some of the advanced concept such as mapping data with colors. So we can call it as a color mapped data. So often what happens, we want to have a third dimension in a plot represented by a colors in a color map. So matplotlib has a number of plot types that to do this. Example, we have the in the color maps. The basic thing is there are all examples of artists that derive from a scalar mappable objects. These are all called scalar mappable objects. So objects so they all can set a linear mapping between Vmin and Vmax into the color map specified by CMap. So Matplotlib has many color maps to choose from, and you can make or else you can create your own color map from the Matplotlib. Okay, so and one more thing that I want to look into before we start creating color maps, the first and next thing is normalizations. So what is normalizations? Sometimes we want a non-linear mapping of the data to the color map, as in the log norm. So example, so we will be doing that log norm. So to do that, to create that log norm kind of thing, by supplying the scalar mappable with the norm argument instead of vmin and vmax. So this example also we'll be looking. And then finally there is one more parameter that we'll be looking into is color bars. So adding a color bars gives a key to relate the color back to the underlying data. Color bars are figure level artists and are attached to a scalar mappable. So scalar mappable, whether they get their information about the normal and color map, and usually they steal space from a parent axis. So placement of color bars can be complex. Uh, you can also change the appearance of color bars with the extend extend keyword to add arrows to the end, and the shrink and aspect to the control the size. So finally the color bar will have a default locators and formatters appropriate to the norm, so these can be changed as for other access objects. So what we will be doing is we'll be using this scalar mappable and then respective vmin vmax, and then in addition to that we will be using norm argument norm, and then color bars. Using all those things we will be creating a color mapped data. Let's do that. Okay, let's take one example, x comma y, and we'll take np dot mesh grid directly, mesh grid, and in between first would be np dot linspace. I'm gonna add an arrow, sorry, an array. So it consists of -3 to 3, and I want it into 128 fractions. Then the next argument would be, it's like x. This is the first argument is the data that is going to be plotted on x-axis, and the second argument is an array that will be plotted on y-axis, linspace, and this one would be from -3 to 3 till 100. Okay, so till I'll go with the 128 same, and let's execute. So let me print x. Yeah, you got the values proper, and array and y. Yeah, no problem, you got the data now. So now let me create z, that is equals to, it's an equation, I'm creating an equation. So 1 minus x divided by 2 plus x power x to the power 5 plus y to the power 3. So this is a complex equation, and I want to multiply this equation with the an array of np dot exponential of minus x square and minus y square. So that's what is our z. Let me execute and try to print z, whether we got the respective values or not. And let's see. Yeah, we got the values. This is what the z, a complex three-dimensional one, x, y, and so it consists of two dimensions in it, x and y. So both, it's 1 minus x divided by 2 plus x to the power 5 plus y to the power 3, and multiply whole thing with an array of minus x square minus y square. Okay, well, obviously all these calculations will be happening at the element level. So now let's create a figure. Let's create a plot. We'll say fig and axis is equals to plt dot subplots. As usual, this time I'm gonna go with 2 comma 2 2 by 2, and layout is equals to constrained. Okay, yeah, you got the plot. You got the plot with the 4 subplots, so absolutely fine. Now it's time to draw. It's time to draw the figures. So PC is equals to axis, correct? Then inside that I'm going to take 0 comma 0, the first one. Okay, so total how many we have? 1 2 3 4. So let's take the coordinates of each one. So if you take 0 comma 0, then 0 comma 0 is this, 0 comma 1, and then we have 1 comma 0 and 1 comma 1. Clear? So let's take the first subplot, and for the first subplot we are going to create a p color mesh. Okay, I'm gonna use p color mesh. Of, I'm giving the values now, x comma y comma z. So total 3 parameters I'm giving to it. And then as usual, as we have discussed earlier, so we'll give v min, that's -1, and v max, that is 1, and finally c map, I'll give rdbu underscore r, and execute. Here is that. Looks brilliant. I liked it. These are the colors basically. rdbu underscore r, colors. So now let me add few more things to that. Let me add a color bar just to optimize the look. So fig dot color bar and PC, and add ax is equals to axis of 0 comma 0. And here is that. You got the color bar. See how nicely it's looking. So overall, so using a color bar and then a color mesh and color bar, we have representing the data, our data with the colors. This is what we call it as mapping the data using colors, or color mapped data. So that's what we were talking here also. So we used the color maps and we'll use a color bar. So at this, so far we used color map and color bar, and we have created a one plot, and after that we'll use normalized and then we'll use all 3 components, and we will enhance the visualizing ability of our color map. Okay, so that's one. Then let me add few more things to this. The first graph, I'll say subplot 1. So let's say subplot 1, 2, 3, 4, like that from top. So axis of 0 comma 0, that's the first one, and then set of let me set the title for this, and the title would be P color mesh off, and it's getting ready. It's done, all done. So now let's work on subplot 2. Okay, so in subplot 2 we'll take a CO. Okay, this is counter. So CO is equals to, let me take the same one. It's let me copy that, and let me change this method from color mesh to contour 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 F, and let me change this to 1 contour F, and contour F XYZ remains same. Here the things will change from level. The next one after this, I'm gonna add a levels argument, and then levels argument np dot linspace, and linspace of we'll take minus 1.25 to 1.25 and make it into 11. Okay, and execute, and here is that. Oh, brilliant. Contour is looking brilliant. The contour is looking brilliant now. So after this, let's add fig color bar to the same, so that color bar is minimum requirement, so that we can have an understanding what it is representing. Let me put 1 and execute, and here is that, your color bar. Brilliant. Then we'll attach the final, that's the title. We'll set the title, and we'll see how does it look like. The title is nothing but I'm gonna give, as usual, contour F, and it's 1, and execute, and here it is. Brilliant. Now let's work on subplot 3. So for the subplot 3, I'm gonna say PC axis of 1 comma 0, and dot, I'll go the imshow method, and z square times 100, and cmap is equals to plasma. This is what the arguments that we are providing inside that. And the norm, see here we are using the norm mpl dot colors dot log norm, and now we'll use vmin is equals to 0.01, and vmax is equals to 100. That's it, all set. Let's execute and see. Name Z is not defined. Okay, that's my mistake. Let me convert this into the capital Z. Anything else? Yep, no issue, absolutely fine. You got it? Wow, 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 wow. So now let's add few more things to that. Again, let's add a color bar. Let's scroll up. So okay, so where I'm copying, I want to copy it here. Yeah, change this to 1 comma 0, and execute it, your color bar is ready. It's a log color bar. You see that 10 power minus 2 minus 1, 10 power 1 and 10 power square. That's what we were talking here. You see, normalization, sometimes we want a non-linear mapping of the data to the color map. In that case, we have to go for the log norm. Okay, you see that that's what we did here. Norm MP, and we have used the log norm method, and it's using that Vmin and Vmax. So now let me add the title to this. Let me copy this and paste it here. So 1 comma 0, 1 comma 0, and the title would be I will add it as okay, I'll put it in a different way for this. Set title, I'll say as imshow with imshow. We are using imshow method there. Imshow with log now. Brilliant, brilliant name, brilliant title. Then on top, it's similar. It's a PC, and then AX 1 comma 0, and I just want to extend to the both sides. So extend is equals to both. Yeah, and here is that. You got the proper design. It looks nice. It looks brilliant. So this thing has been extended to the both sides, on top and on. It's looking brilliant. That's good. That's correct. So now let's look into the one more, and even we got the title also here. The title is imshow with log now. So we'll do it for the subplot 4. So subplot 4. Let's take the top one because it's just a scatter plot. We'll take the same one, this, yeah, and paste it here. We'll do slight modifications here, nothing much. From the color mesh, we'll change it to scatter. And we'll also change the grid. It's 1 comma 1 because that's the last one. It's a fourth one. And then scatter x, y, z. Okay, in spite of using x, y, z, the data one that we have made before for the previous examples, that we'll use data 2 and data 3. Let me check C as a data 3, and that's it. We'll keep the C map, that colors remain same. Yeah, the rest all fine. So if you are not sure where we have created data 1 and data 2 and how to create, I'll show you. Just a minute, just give me. Yeah, here we are using data 1. Yeah, okay, my plotter. Yeah, data 1. So this is how we created the data 1 and data 2 using random. Okay, so now that's clear. So now we will look into the let me change this. I want to attach a color bar to this, and I want to extend it on both sides. So I'll keep the PC same and extend on both, and the site title would be scatter. That's it. Oh, what happened to the scatter? Okay, uh, place, let me change this, 1 comma 1, that's it. And here is it. Got it, all set, all done, all ready. So this is how we do the mapping of the data with the colors. Let me show you this one more time. Yeah, this is how we use the color to reflect, to show, and to create plots on data. This is how we map the data with the colors.